Hi grade 9s, welcome to the video for your Unit 2 Day 3 lesson. Just like the Day 2 lesson, this one's pretty big, so we've divided it up into two separate parts. This is Day 3A, so we're going to talk about the third and final exponent rule that we're going to look at in this course. In Day 2, you guys learned the exponent rules for multiplying and dividing powers with same bases. This third exponent rule is going to be called power of a power. And like in the Day 2 lesson, we're bringing this one up into the first day where we're only going to look at single bases of a variable base and then going to extend that when the bases could be numbers or when the variables could have coefficients in the Day 3B lesson. So getting into the first example, this chart should look pretty similar from the last couple of lessons. It's a little bit different. Here we've got an original expression and we're going to expand it out and talk about what the simplified form of that expression is. So here we have a cubed and then that whole thing is in brackets and it's squared. So we know that anything squared means that thing times itself. So a cubed squared means a cubed times a cubed. Then if we take this, we can multiply this as a times a times a, and then again a times a times a. So altogether there ends up being an answer of a to the exponent 6. So you can look back at these original exponents, a cubed all to the exponent 2, and see if you can make a guess as to what the power rule is going to be here. We're going to do the next one. It's a squared all cubed. So this is a slightly different meaning. This means a squared times a squared times a squared. So the other one meant 2a cubes. This one means 3a squareds. But I'm going to write out each one as a times a. So a squared times a squared times a squared. We end up with 1, 2, 3, 4, 5, 6 a's all multiplied. So that's also a to the 6th. The next one, I'm going to have trouble fitting this in, I think. A squared to the exponent 5. So this means a squared times a squared times a squared 5 times. I'm going to have to I think I'm going to go on 2 rows here. So this is a squared times a squared times a squared times a squared times a squared. So it's 1, 2, 3, 4, 5 a squareds. And then I'm going to expand that out. Again, just using 2 lines to fit this in. Each a squared is a times a. So then a times a, and I have to do this 5 times because I had 5a squareds. And one more. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 a's. So it's a to the exponent 10. So hopefully you guys are noticing a pattern. What do you think this one's going to be? A 7 to the exponent 2. So this is going to be a7 times a7, a to the exponent 7 times a to the exponent 7. And then again, I'm going to need 2 lines to expand this out because each one of these is going to be a times a 7 times. 4, 5, 6, I think I'm 7. And then again, oh, that's a lot of a's. Okay, so I hope that you guys have kind of seen a pattern. What happened with these exponents? I ended up with a to the 10. What would happen here? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is a to the 14. So I think that you guys are seeing likely that the pattern here is that we're going to be multiplying those two exponents together. So we're going to generalize this and write down a rule If we have x to the exponent m, and then that whole power raised to the exponent n, that's why this is called power of a power. So I've got a power inside, and then that's also raised to another exponent. So it's a nested, it's like a power within a bigger power. This is going to be x to the exponent m times n. The rule here is multiplying exponents. If you have multiple powers inside that bracket, you're going to multiply each exponent by the outer exponent. So this would be x to the exponent m times a and y to the exponent n times a. So when a power is raised to another exponent, you multiply the exponents together and keep the base the same. So here in the example, there's a multiple choice. We have x cubed to the exponent 7. So this is our inner power, and then we've also got a power going to the exponent 7. So this is power to a power. We get x, keep the base the same, and multiply the exponents, 21. So we see that B is the correct answer. So common mistakes. Sometimes people kind of see an x to the 10, thinking back to the multiplying rule. Remember, the multiplying bases that are the same base, we add the exponents, but this isn't the same base. It only has one base. It's one base to two exponents. So those exponents get multiplied together. So we're going to simplify here. In A, we have one base to one exponent and then another. So it's a power within a power. We keep the base the same and multiply the exponents. So I get x to the exponent 40. And thank goodness I don't have to write that one out. I would run out of room. Here I have multiple bases. Each individual power is going to the exponent 4. So I'm going to keep the first base the same and multiply the exponents. So 7 times 4 with that outer exponent is 28. And with the n, I keep the base the same. And I'm going to multiply the original exponent of 3 times 4. So I get n to the exponent 12. We could combine this power of a power idea, also with the multiplication and division rules that we did in day 2. So here I'm going to, for part C, we're going to simplify x squared y cubed, and this is all to the exponent 3. So we've got a power within another power. We're going to keep the bases the same and multiply the exponents. So on the numerator, I have x, and I'm multiplying the original exponent 2 by that outer exponent 3, so I get x to the 6. I have a base of y, I'm going to keep that the same, and multiply the original exponent 3 by the outer exponent 3, so I get y to the exponent 9. And then on the denominator, one thing to be really careful of, I have x times y squared all squared. So remember, if there's no exponent, it's an exponent of 1. If there's not an exponent listed, you just draw a 1 in there. And then follow the rules the same way. So for my x, keep the base the same and multiply the exponents. 1 times the outer exponent 2 is 2. And the y's, keep the base the same and multiply the exponents. The inner exponent 2 times the outside exponent of 2 is 4. Now this goes back to one of the questions that you would have done in lesson 2. I now have dividing and I have same bases. So here I'm dividing two powers, both with base x. I'm going to keep that base the same and subtract my exponents. 6 minus 2 is x to the 4. Over here, I'm dividing, and I have both base y. So y to the exponent 9 divided by y to the exponent 4, keep the base the same and subtract those exponents. So that's one of the rules from the day 2. Okay. Here we can simplify first. So here I've got division within these brackets. Remember that we want to evaluate or simplify anything we can within brackets. That's always our first step in BEDMAS. So I'm going to simplify. I have 2 powers with the same base and I'm dividing them. So I'm going to keep the base the same, subtract those exponents, and then I'll deal with that outer exponent of 7. So now I have a simplified power to another power. That will give me m, and I'm multiplying exponents for 28. We have another example where we have to simplify and then evaluate. So here again, you always want to make sure that you're simplifying as much as possible. We don't want to go putting in x equals -2 and y equals 3 in this big messy question. We want to simplify it as much as we can and write it in an easier form before we go and substitute in those numbers. So the first thing I'm going to look at, grab a different color here. I have this bracket to this power 5. That's power of a power. And you can see that kind of repeated with this bracket to the exponent 3 and the denominator bracket to the exponent 8. So I'm going to multiply using my power of a power rule. I'm going to work out this exponent. So here I get x, keep the base the same, and multiply the exponents. The 7 inside and the 5 outside is 35. And then my y, keep the base the same, multiply the exponents. 6 times 5 is 30. And then I'll do the same thing for that next one. My next bracket is raised to the exponent 3, so using the power of a power, I'm going to multiply that 3 by the exponent on each of the variables inside. So I keep the base the same as an x, and I do 5 times 3 is 15. Then I keep the base the same with y, and I do 4 times 3 is 12. The last one here that I'm going to look at is the denominator. Same thing, I have a power of 8, and I'm going to use power of a power and multiply that into both of the exponents on the inside. So keeping the base the same, I have x. 5 times the 8 is x to the exponent 40. And then y also will be 40 with 5 times 8. Now we're going to go through a few steps because this looks like a question that you had in day 2. We're going to combine in the numerator, looking for things that have the same base. I have x to the exponent 35 and x to the exponent 15, and I'm multiplying those. So here, if you're multiplying, you keep the base the same and you add up those exponents. 35 and 15 is 50. Y, I'm going to multiply again, adding up those exponents. I need to keep that base the same and add up the 30 and the 12, and I get 42. This will be divided by x to the exponent 40 and y to the exponent 40. Okay, now again, we're looking for common bases with our division. We've got an x to the 50 and an x to the 40. When I divide, I get x to the exponent 10 by subtracting the exponents, keeping the base the same. With the y's, I'm doing y to the 42 divided by y to the 40. 42 take away 40 is y squared. Now this is as simplified as I can get it, and now I'm ready to look at substituting in these numbers. So just to kind of keep myself up on the screen, when you're doing this on paper, if you have enough space, I maybe do here, but you could keep writing down. I'm just kind of keeping this centered on the screen so you guys can see. I don't want to go off the edge of the video here, but there's no other reason for me to do this arrow. Normally you just substitute it in and keep going down below. So I'm going to substitute in a value of x as -2 using brackets to the exponent 10, and y is 3 to the exponent 2. So I'm putting in my x value and my y value. Now, thinking about the negative sign here, this will be negative times negative 10 times. If you have 10 negatives, remember that 2 negatives is going to give you a positive. So those are actually going to pair up. You can also do this on your calculator if you want, but this gives you 1024 as -2 to the exponent 10 times 9. So then we're going to multiply those, and the final answer is 9,216. So that's the final answer. There's one thing that I do want to point out to you, and this may depend on your calculator. I'm going to grab a different calculator. So if you were doing -2 to the exponent 10, if you do -2 and then my exponent button here, 10, this one does give you a positive number, even if I don't put in brackets. But some calculators, you do need to put the brackets around it, or you need to be very careful of watching that negative and positive sign. So you may have to use these bracket buttons on your calculator to get the proper answer there, because it is important that that -2 is in brackets. One more example in today's note. So here we're given a cube, and we want to find an expression for the area, the surface area, and for the volume. And we know that the length of one side of this cube is x to the exponent 5. So volume of a cube, remember from grade 7 and 8, that's length times the width times the height. And in a cube, these measurements are all the same. Every side is the same. So the volume would equal x to the 5 times x to the 5 times x to the 5. So we know from our exponent rules, here we're multiplying different terms with the same base. The rule for multiplying is that we add up those exponents. So we get x to the 15. That's a simplified expression for the volume for this cube. If we wanted to find surface area, remember surface area is the area of each side added together. The surface area for a cube, each side is going to be the same area, luckily, because it's a cube. And on a cube, and you can think of a dice to help you kind of picture this, you've got 6 sides. So it's 6 times length times width, or times side squared. And because it's a cube, we're going to say that 6 times the side length squared. So here we know our side length is x to the 5 squared, and then using our exponent rules, this one is power of a power. I've got x to the 5 and then squared, so that's going to be 6x to the power of 10. So that is it for the day 3A lesson. You guys are going to have a second part to this lesson that will be linked in a separate video.